Hi, good morning. Yeah, welcome. Thanks for coming along. This is going to be an intro talk to Metasounds. It's kind of a beginner's guide, a 101 to get you going. It's really exciting to be following on from Aaron and Dan and Grace and seeing all the exciting stuff they've got coming up in the 5.1 release. And really fitting, actually, because it was a talk by Aaron and Dan a few years ago that kind of inspired me. I think it was a GDC talk from 2 or 3 years ago that inspired me to kind of get on board with looking at this stuff. So that was pre-Metasounds, and that piqued my interest in looking at what we could do with Unreal Engine for sort of interactive audiovisual experiences. Bit of a start there. Yeah. So yeah, the target audience for this were sound designers, DIY game developers, multimedia artists, and creative technologists. But anyone really with an interest in creating interactive experiences. And as I said, this is aimed at beginners, but we'll assume some basic exposure to DSP or synthesis. And so any familiarity with like sound design tools like Maximus P, SuperCollider, Pure Data would be beneficial, but it's not essential. So a little bit about me before we start. So my name's Matt Spenlove. I've been working at the intersection of art, music technology and network culture for around the last 20 years. I'm the director of a company called Sonatus in London. It's a creative production company where we work with artists, musicians, industry clients to research, develop and deliver innovative projects for installation, performance and online presentation. So my personal creative practice involves composing and engineering electronic music, designing digital audiovisual experiences that have resulted in international commissions for festivals, clubs, cinemas and galleries. So in recent years, I've completed focused research and development projects investigating the creative applications of game engine and XR technology and the application of that within the cultural sector. Yeah. So we've got quite a lot to get through, but broadly speaking, we'll just set the scene with introducing the Metasounds editor and doing a obligatory Hello World example. We'll make some sound, looking at Wave Player and building a monosynth. And then we'll look at taking that sound and integrating it into the wider engine. So as has been mentioned, Metasounds is a procedural audio engine. And procedural audio, as defined by Andy Farnell in his seminal Designing Sound book, is sound as process rather than sound as data. A living sound effect that can be run as computer code and can be changed in real time according to unpredictable events. So sounds are non-linear and often synthetic. They're created by a set of programmatic rules and driven by gameplay inputs. So practically speaking, procedural audio affords a great versatility in sound design and a tighter, more meaningful integration of sound and music within the interactive experience. Okay, so we're going to jump into UE5 and look at some basic patches. So I have to do some juggling here. I think it's going to be all right. So this is a templated project that is just created from the new project dialog. I just took the blank template, accepted all the defaults, and created the project that way. So inside that, I have a bunch of content related to each of the slides. And to start with, I've got this Hello World Metasound. Okay, so to introduce the authoring environment, what we see on the right-hand side is our design canvas. This is where we patch together the various different nodes to create our Metasound graph. On the left-hand side, we have the members and details pane, where we can see information about the various different inputs and outputs to the system, the interfaces that we implement, and any details about the inputs and outputs is shown down the bottom here. At the top, we have the standard sort of housekeeping menus. Loading up, saving Metasounds, some properties around the Metasound itself and the underlying source audio. As Aaron mentioned in the previous talk, a new Metasound source will inherit a bunch of inputs and outputs. So we've got a standard sort of on-play event to trigger the Metasound, and of course an audio output on the right-hand side of the screen. Over here. And you can see these reflected in the inputs and outputs section at the top. Click on them to get the details. So we've got a couple of nodes here on the graph. We've got a sine wave generator, that's got a number of inputs on the left-hand side and then a single output, an audio output on the right-hand side. The inputs are color-coded, with red being Boolean values, green being floats, pink being audio rate, and white being control events. And the teal at the bottom is enumeration types or collections of predefined values. We can see we've got some defaults. So this is a sine wave generator at 440 Hertz. So let's give it a quick play. Okay, so our sine wave is having an amplitude envelope applied to it. That's actually looping. So we just multiply the output of the sine wave, the audio, by the amplitude envelope and route that out to the output of the system. And again, we've got some input and output values that we can manipulate here. One of the things we might want to do is add a user interface widget to control some of these input values. So I can patch out of the attack time, drop it on the canvas, promote to a graph input, and I get a UI widget by default. And if I play that now, we can see how we can interact with the patch. It's important to note that that input has now created a new input on the left-hand side over here for attack time, and that these inputs are published externally to the Metasound so they can be interacted with in real time. All right, so the maturity of sampling technology saw a shift away from the primitive synthesizer chips in early game consoles and personal computers. So sample-based approaches are attractive for their realistic capturing of real-world sound with a fidelity of recording such that our ears feed our perceptual systems convincing reproductions of the source material. So before we look any further into the DSP-based procedural audio systems, let's first create a patch using a sample-based approach. So that will use the wave player node. Okay, so I've already dropped a wave player node onto the graph here. Actually, I didn't cover that before, but the way you do that is right-click on the canvas, and you can navigate the various different generators, inputs and outputs, etc. So we can see on the left-hand side, it's got a number of inputs, mostly to do with setting the source material and manipulating the playback head within that sound file, and dealing with the looping parameters and the loop duration, etc. And then a number of mostly metadata outputs, but obviously a stereo output going to feed the system. And we can select, I've already got a sample selected in here, so you can change it by using this drop-down. You can drag and drop on top of that. There's various different ways to kind of update that sample. But the samples were imported into the project separately. I just had a folder underneath the content directory that I used to import. So if we take a listen to that. Yeah. There you go. So sample playback 101. So one of the things we might want to do is add some variation to our sample playback. And we can do that with using a randomized get from a collection of samples. So in this patch, I have a samples variable. There we go. And you can see on the left-hand side that there's 11 items in this variable array. And if I drag it out a little bit, you can see there's a number of samples that have been added, and similarly you can update them here, choose different samples. You can drag a collection in from the content browser below. Yeah. So let's just play it first, actually, and take a listen. So what we're hearing is a number of finger click samples, one of the 11 that were imported into the project, being played at a period of 800 milliseconds. And so the way this works is that the on-play event triggers the patch. That starts off a repeating trigger that will repeat every 800 milliseconds or the amount specified by this period. That feeds into a random get node, which takes in the collection of samples, selects a random sample each time it gets triggered, passes that value output into the wave player, which is kind of where in the realm of where we were before, and then just passes on the trigger event and outputs that to the system. Okay. You can also take in weights and repeats. So should you want to highlight particular samples or increase the probability that certain samples in your collection will play, you can kind of use a set of probabilities to sort of achieve that. So taking the idea of randomness and to its logical conclusion for maybe more of a kind of creative use, I have this hot mess here, which does this kind of thing. Okay, so it's a very sort of crude, like auto music concrete generator. But basically, we're just taking that idea of like using random sample selection, moving the playback head within that sample, various different loop points, messing with the loop points, and messing with a little bit of delay at the end to get that kind of effect. Okay, so next we'll look at doing some DSP stuff. So, these sample-based techniques are effective and productive in many situations, but we can go much further with meta sounds and create, a malleable audio that's not reliant on using like fixed snapshot source material samples. This is going to provide us with extra power and flexibility when using physical modeling techniques via raw DSP. And we can model an object's sonic attributes and publish those attributes to the rest of the system for interaction within the game environment. So to demonstrate this concept, we'll start more simply with just the basic synthesis techniques, and this is more useful for composition rather than sound design. And so we'll look at building out this sort of monosynth style patch, which is just a classic synthesizer module. You've probably come across it, playing a single voice at a time, often used for bass lines and solos, Roland TB303, Korg MS-20, SH101, that kind of stuff. So let's jump back in. Okay, so the first version of this monosynth, we just have a single oscillator or generator in the graph. So that's a sawtooth generator, just a sort of harmonically rich sound source. And that's patched into a simple two-channel mixer with a volume to allow us to control the volume of that particular oscillator. We routed that out into a biquad filter, so we can control the tom rule content of the sound. And we have a couple of user interface widgets for doing the controlling the cutoff frequency and the bandwidth or the resonance. And then that's routed to the output of the system with just the master volume control. So if we take a listen to as it is. Okay. So there we have it, just a simple sawtooth with some colorization of sound. Stepping forward. So in this updated version of the patch, we can see that we've got multiple oscillators or generators. I've actually got a Metasound sub-patch here. We'll go into that a little bit more later. But we can see we've got a number of generator outputs. So for saw, noise, square, like a sub-oscillator, and actually some FM as well. And as you might expect, that's routed to a larger mixer to allow us to control the individual volumes of each of that. We're going to the same filter, but this time I'm applying an envelope generator to the filter amount, so we don't have to control that value. And I just have a little bit of extra patching in here to allow us to set a ratio between the attack and decay of that envelope so that it stays in sync with the period of the sequence. It doesn't overflow the period of the sequence length. We then send that out to an amplitude envelope that has a similar structure. It gets applied to the sound before being routed into some delay at the end. question. All right, we can have a lot of fun with that. Oh yeah, so just maybe show you the delay a little at the end. So just bringing up the right amount of delay. And lastly, a little bit of that FM voice. And yeah, thank you. And yeah, I just mentioned that because I use that later in one of the presets that we go into. So yeah. So you can see that, you know, with a reasonably small amount of patching, we can get a decent sounding kind of monosynth style patch, and that can be like a fundamental, you know, generator of sound in our meta sounds. We can build presets on top of that, have various different patches, different timbre characteristics, different use cases. Okay, so far so great, but like everything we've seen so far is just working you know, only in the meta sounds editor, and you know, where the real power comes is when we start to integrate within the rest of the engine. And before we get to that, I should mention a little bit about patch reuse. Am I feeding back, or is it just my ears? Okay, right. Yeah, so there are two types of meta sound assets that we can use in our sound design. So what we've seen so far, the first one is a meta sound source, which is the top level asset that we can use and add directly to our gameplay scene. And this could be triggered and interacted with, and everything at this hierarchy as its inputs published to the rest of the system, so we can interact and manipulate it. The second type is a meta sound patch, and that allows us to create custom nodes that we can reuse inside our meta sound source graphs. And so a concrete example is the oscillator bank that I showed you in the previous monosynth patch, or perhaps a sequencer that we could, you know, create and then reuse across different versions of our meta sound sources. So let's jump back. All right, so you can see this is a sort of slightly stripped back version of the previous monosynth patch. And at the minute, we don't have any oscillators patched in at all. So what I'm going to look for is a previously made oscillator bank, this one, 06. I can zoom a bit more. Yeah. So we want to take the sawtooth output, patch that into the first input in the mixer, the noise into the second. We take the output from our sequencer into the frequency, and our glide amount into that. So I glossed over the sequencer before, but all we really need to take away from it is that we can select, it's a Metasounds patch, sub-patch. We give it a collection of note values, and it will iterate over the first 3 of those and randomly select another one from the collection at a point in time. So it just gives us a little bit of variation in a fairly straightforward sequence. But again, it's a kind of, you know, monophonic style sequencer. So now that we have an oscillator bank patched in, we should be able to play the patch and get some sound. Yeah. Okay, just to make sure that everything. Yeah. And a little bit of noise in the background. So one of the things we might want to do is update this Metasound patch, the oscillator bank. So we double click it, we can open it up and inspect it. And it's very straightforward. We can see we've just got the 2 generators, some input values, and the 2 audio outputs. So we might say we want to add a square wave. Oh, tight. So we can add that in to the sub-patch, take the same frequency value and the glide value. And we need to create a new output for it. We drag out and promote to graph output. can see it's correcting them over here. So we can do. And the last thing I want to do is just adjust the sort order. So I want this to be the third output that's in the parent sort of Metasound patch. So I'm just going to adjust that to be 2 because it's 0 based. And if we save that off and go back to the parent, we can now see that that's been made available and we can patch it in. Okay, and we can see that we've got our newly created square wave being fed into the patch. So if we revisit the quote from the start about procedural audio, sound is processed rather than sound as data, a living sound effect that can be run as computer code and can be changed in real time according to unpredictable events. So we'll note that we've covered the first part of this by creating Metasound patches and that generate DSP in real time. And now we need to turn our attention to the second part, which is looking at interaction and integration. So we have 2 mechanisms to deal with integration within the gameplay and create those kind of unpredictable events that we're looking for. And the first is to implement interfaces, which Aaron mentioned before if you're in the previous talk. And this creates a sort of push-style data flow that allows our creations to be reactive from predefined gameplay parameters, such as distance-based attenuation or relative spatial position. The second is publishing Metasound source inputs to the wider engine via blueprints. We won't go into the detail about how you wire up the blueprints in this session, but we will show an example of using that within the wider gameplay being controlled by sequencer. So let's jump back. So far we've done everything inside Metasounds and we've not actually played our game level at all. So the first thing we can do is take this version of the monosynth and just drag it into the scene. Hit play. Okay, unexciting but also kind of amazing as well, right? That's just like our Metasound straight into the game, yeah. But it's not doing anything at the minute, it's just playing. If you move around in the scene, it's just going to play all the time. There's no, nothing particularly exciting about it. So what we might want to do is go back and implement a distance-based interface. So again, on the left-hand side over here, we can see that we can choose from one of the 3 currently available interfaces. We want to take the attenuation interface. That's given as a new input up here on the left-hand side under the sort of UE category. All the other ones are custom ones that I've created. Can drag that input into the scene, take the value. I'm just mapping the range of it because I've figured out some decent values before, and we're going to take the output of that attenuation. So we're talking about the distance between the player and wherever the Metasound is within the game level, and we're going to use that to control the sequencer period. Okay, now I need another hand. So if we play that now. Okay, so yeah, as we get further away from the sound source, we can hear it slow down. Oh. It's exciting. Yeah, okay, so a really simple example, but it starts to give you an idea of how you can sort of get the integration happening within the Metasounds and yeah, interact within the game. So interfaces provide a flexible way to allow independent parts of the game engine runtime to communicate with our Metasound sources. And the patches then assume these sets of behaviors. And so there are only a handful available at the moment, as we saw in that drop down, but as Aaron alluded to earlier, there's a lot more potential kind of coming down the line for that sort of stuff. So imagine you could get a direct feed of parameters relating to listener data for your first-person avatar, or grab like geometry or occlusion information from objects in your scene. And the interfaces are agnostic, so it'd be possible to allow developers to define their own interfaces that might enforce some sound design within the game or custom gameplay system that they've sort of using within the game that you're creating. Okay, so the second method for integration is blueprints, and we'll look at an example of that via the sequencer. So blueprints allow us to publish any arbitrary metasound source input parameter to the rest of the game. So where interfaces inherit predefined game engine parameters as groups of behaviors, publishing via blueprints affords us greater flexibility to interact with any aspect of the wider game engine or system. So we can publish any input and interact with that with any of the existing UE audio systems, or sorry, engine systems. So that's done via the blueprint visual scripting, which is the default way to model game logic and behavior inside UE. And it's a first-class system that allows you to interact and manipulate with actors and components inside your scene. So then Sequencer is UE's multi-track editor for creating and previewing cinematic elements in real time. So we can create level sequences and add tracks to animate the parameters of actors or components. So maybe we're going to fly a camera around the game level. Yeah. So once we have a blueprint that encapsulates our metasound, we can address any of those parameters via Sequencer, just like it's any other component within the game. So actually what I have here is a preset that I made earlier of the monosynth metasound source that we created. And it sounds a little bit different, and the FM's been dialed up on it. Oh, I can preview it here. And I've already created a blueprint based off of that preset. And you would do that by right-clicking Asset Actions and create blueprint using this. And there's a little bit of plumbing involved to expose the inputs. But we can see here's an example blueprint I created before. So we can add it into the scene, look at the details, and we can see, if I filter here, yeah. So there's a number of inputs that I've exposed. And if we play, we'll be able to manipulate these in real time. Oh, I need to get rid of that one. How do I do that? That one. Let's get him highlighted first. All right, there we go. Okay, moving up. Okay, so we can see we can bring up the sub amount and the FM. Okay, so that's cool, but obviously we don't want to be doing this manually at runtime. So what we can do is add a level sequencer to our level. And we do that with the cinematics menu at the top. Add a level sequence. We'll just stick it in the root of this content directory. Okay, so you can see we've now got a timeline-based sequencer at the bottom. And we can use that to interact with those parameters of our Metasound preset blueprint. Yeah, I said all the right words. So we can add a track to that, actor to sequence, and we can locate the blueprint that we created before. And if we add a track into the sequencer, we can see that we've got some of the parameters already available to us here. So I could add the sub amount. I have to do this. So I'm just going to add a number of keyframes into the sequencer to animate the value of the mixer sub level over time. So I've had a keyframe there. We'll leave it at 0. I move to halfway through, add another keyframe, 0.7, 0.8 maybe. And then jump to the end of the sequence to bring it back down to 0. Add a new keyframe there. Okay. So now what we should hear when we play it is the sub rise up into the middle and then try it off at the end. Or not. There we go. The sequence has also got quite a nice curve editor. So if we add in another track for the FM, and then open up the curve editor here, you can see that they're available. Let's just play the level. So we can create keyframes within the curve editor here as well. So let's add a couple. So we'll do it the other way around. So we can hear we're kind of crossfading there between the FM value and the sub. So this curve editor is a really nice editor for doing kind of, multi-stage envelope generation and feeding that into your meta sounds. Okay, that was a lot and it was quick, but just to revisit what we talked about. So we started with the concept of procedural audio and reviewed why it's important and powerful in experience design and how it underpins the design philosophy of Metasounds. We then introduced the editor and the runtime. We took a look at the sample-based approach for creating sound effects or sound design and using a little bit of randomness and variation to kind of add a more natural feel to that. We then really unlocked the power of Metasounds by looking at DSP, creating a monosynth subtracted synthesis style patch. And afterwards, we integrated the monosynth into the engine using interfaces, and then controlling the monosynth preset via a sequencer at the end. Okay, thank you very much.